state of stress at a point is sigma x equals 10 kpsi, sigma y equals negative 30 kpsi, and tau xy equals 10 kpsi. Draw a complete Mohr's circle diagram, label all points of interest, determine the principal stresses, and report the maximum shear stress for this case. Sigma x is the normal stress in the x direction, and sigma y is the normal stress in the y direction, and tau xy is the shear stress in the xy plane. Next, calculate the center of the circle C, which is known to be at sigma x plus sigma y divided by 2 and 0. Next, determine the known stress states. These points are sigma x, tau xy, and sigma y, negative tau xy. Next, calculate the radius r using the equation square root of sigma x minus sigma y divided by 2 squared plus tau xy squared. For this MohrsCircle, the principal stress, sigma 1, is calculated using the equation C plus R. The other principal stress, sigma 3, is calculated using the equation C minus R. Since sigma 3 is less than 0 and sigma 1 is greater than 0, sigma 2 is then known to be 0. The maximum shear stress, tau 13, related to the principal stresses sigma 1 and sigma 3, is equal to the radius r of the circle. The maximum shear stress, tau 12, related to the principal stresses sigma 1 and sigma 2, is equal to sigma 1 minus sigma 2 divided by 2. The maximum shear stress, tau 23, related to the principal stresses sigma 2 and sigma 3, is equal to sigma 2 minus sigma 3 divided by 2. This finishes all calculations for the MohrsCircle. The completed MohrsCircle shows the principal normal stresses and maximum shear stress. The principal stresses are sigma 1, sigma 2, and sigma 3, and the max shear stress is tau 13.